This laboratory is about the optical comparator. Within the handout, you'll notice that this machine takes comparison measurements by using a projected light onto a calibrated grid screen. And you'll notice on the table that we have our components that we're going to measure shortly. On the optical comparator, you'll also notice on this platen, or movable table if you will, it will allow you to move the component around to adjust properly and within focus on the projection screen. There is a vernier pair of calipers here and a extension dial indicator that will allow you to move things around, and you'll know exactly how much you moved it. The webcam does not pick this up very well, but every mark is 5 thousandths, 0.005 inches. Like for instance, if you can make this out on the camera, that's 0.450 on that line, and then you'll notice down here it's 0.500. So you're going by 50 thousandths from 450 to 500, and that's adding 5 thousandths for each mark, and that's also true going horizontally for a component. Now I'm going to move the camera up real quick. We're looking at a nail head. I'm able to move this around so you can get a picture of what's going on. Like if I want to do the diameter of the nail head, I raise the height of the component. As you can see, I'm moving it around, and there's 50, 100 thousandths, 150 thousandths, 60, 70, that's about 180 thousandths, or 0.180 in diameter for the head. And that's how you would take a measurement vertically. Now if you wanted to take one horizontally, you could do it a couple of ways. You could just loosen the component and move it over, or you can move this. Now in this case we're going to catch part of this head here, so keep in mind that's 5 thousandths for every mark. So that's 5, 10, 20, 30, 40, 50. It's about 55 thousandths. 0.055 is the height of this secondary head, if you will. This is how we'll do the measurements for all of the components. In this clip, we're measuring the angle of the pointed end of a countersink bit. I changed to a different calibrated grid scale, as you can see, and this has angle graduations on it. I've also set this up on the back part on the template that's behind this front overlay. You'll notice it says 0, 10 degrees, 20 degrees, and it moves on out. And here is 90 degrees right here, and then 100 degrees. Well, with this outside template, I've gone in and I've moved it around, and I've lined up the 0 here, and you'll notice to this first line, this is 60 degrees from here to here, and then if you go from here to here, it's like 45 degrees. That would be 110 degrees, excuse me, 105 degrees. I'm learning how to add here. But if you draw an imaginary line going out here, you'll notice that this falls within the 45, and it comes out to about 84 degrees would be the point on the countersink bit. Here is a better video capture of the countersink bit with the light being projected onto the screen from the part, and you will see the angle of the part on the two grid overlays, the one with the angle behind it as well as the top grid, which has 5 thousandths per increment here, and the actual angle that we were looking at. In this clip, you can see we're measuring hole number 5 in the 8-hole inspection block. Unfortunately, in this clip, it's very difficult to pick up the diameter on the screen. I'm going to try to get in as close as possible for you, but even then it loses focus. But as you can see, that the light is focusing, or should I say being aimed through hole number 5, and then I've gone in and I'm going to change the height a little bit on the hole. I'm going to try to line it up with this axis here, which would be 0, and you have 50 thousandths, 100 thousandths, 150 thousandths, 200 thousandths. It's about 235 thousandths. 0.235 is the diameter of hole number 5. This is how all of the holes will be measured on the 8-hole inspection block. Here are the rest of the components we're going to measure in this optical comparator laboratory exercise. On the angle for the CMM test block, we'll use the one grid template to figure out what this angle is. We'll measure the rest of the holes. On the 8-hole test block, we'll measure the spacing between the gears as well as the thickness of the spur gear, the height of the cutter, and various diameters and lengths and features on these other parts. And then all I ask is fill out the Excel spreadsheet and then turn that in. Unfortunately, there's no calculations for you to do this time. You just have to transpose and copy the numbers that are on my handwritten sheet to the Excel spreadsheet, and you turn it in for a grade. Thank you for joining me today.